What if I told you? James Webb just found a planet that shouldn't exist. A world so hot, nearly 2,000 degrees Celsius, that iron itself would melt on its surface. And yet, this fiery planet somehow clings to thick, shimmering clouds. By every law of physics we know, this world should have been stripped bare long ago. But there it is, defying the universe's own rules. To understand why scientists are so baffled, we first need to talk about a place we call the hot-Neptune desert. It's not a physical desert, of course. It's a statistical one. Out in the cosmos, we see thousands of planets, gas giants like Jupiter, rocky worlds like Earth, and icy giants like Neptune. But in the scorching regions close to stars, where temperatures can soar above 1,000 degrees Celsius, we almost never find Neptune-sized planets. Why? Because at those temperatures, their atmospheres should boil away into space. Gravity simply can't hold on to gas when it's that hot. Imagine leaving an ice cube in the Sahara. In seconds, it's gone. Now imagine trying to keep an entire planet's atmosphere intact at 4 times the temperature of Venus, which is already hot enough to melt lead. Venus burns at about 465 degrees Celsius. But this new world, LTT 9779b, reaches nearly 2,000 degrees Celsius. At that heat, iron, titanium, even glass would liquefy. And yet, this planet still has clouds. Something doesn't add up. LTT 9779b was first spotted in 2020 by NASA's TESS mission, the Transiting Exoplanet Survey satellite. At first, it looked like a curiosity, a Neptune-sized gas planet orbiting blisteringly close to its star, just 1.2 days per orbit, practically hugging its sun. But the real shock came in 2024, when the James Webb Space Telescope took a closer look. Webb doesn't just see planets. It reads their light, peeling back layers of atmosphere to reveal chemical fingerprints. And what Webb found was astonishing. Instead of an empty, stripped core, it detected a thick layer of silicate clouds. These clouds reflect starlight, making the planet unusually bright, almost mirror-like, despite its infernal heat. They're likely made of silicate minerals, the same stuff that makes up sand or glass here on Earth. But in this alien world, they're vaporized, forming clouds of molten rock. And between the day and night sides, fierce winds whip through at thousands of kilometers per hour, redistributing heat, like cosmic jet streams on steroids. All of this happening 262 light-years away in the constellation Sculptor, on a planet that somehow rises, unburned, from its own inferno. So, how does a world like this survive? Here's where things get beautifully strange. Those silicate clouds act like a protective mirror, reflecting a large fraction of the star's radiation back into space. Think of it as a planet wearing a shiny, heat-resistant cloak. And these clouds aren't made of water, like on Earth. They're made of tiny droplets of molten rock that can exist at 2,000 degrees Celsius without evaporating completely. It's the ultimate cosmic irony. The very heat that should vaporize this world instead forges its shield. The clouds rise, condense, and evaporate in an endless, fiery cycle, keeping the atmosphere from being blown away. It's a cosmic paradox. The planet shouldn't exist, yet it does. The laws of physics seem to bend, but in truth, they're simply expressing themselves in a way we've never seen before. LTT 9779b is more than an anomaly. It's a challenge. It forces scientists to rethink how planets form and evolve in extreme environments. Perhaps it began life much larger, a gas giant like Jupiter, and lost most of its outer layers over billions of years. Or perhaps it formed exactly where it is, defying our models entirely. What we do know is that discoveries like this are reshaping our understanding of the universe's diversity. The James Webb Space Telescope, with its unparalleled infrared vision, allows us to peer through the blinding light of stars and glimpse these hidden worlds. Each observation is a reminder. The universe doesn't read our textbooks. It writes its own. But perhaps the greatest mystery remains unsolved. How do these silicate clouds form? And how do they persist, orbit after orbit, under such impossible conditions? Could there be more of these impossible worlds hiding in the data, waiting for Webb's gaze to reveal them? If so, they could hold secrets not just about alien planets, but about our own cosmic origins. After all, the early solar system was once a place of fire and fury too. Molten rock, violent winds, and clouds of vaporized minerals. In studying LTT 9779b, we may be looking not only at an impossible planet, but at a mirror, reflecting the chaos that gave birth to worlds like ours. The universe is full of impossibilities. And yet, here we are. Perhaps LTT 9779b isn't breaking the rules. Perhaps it's simply reminding us that the cosmos is far more imaginative than we are. If you enjoyed exploring this impossible world, subscribe for more cosmic mysteries. Because out there, beyond the stars, we know, the universe still has stories left to tell.